Ever stop to think about just how tightly your body and brain are, well, linked?
It's pretty fascinating, isn't it?
Yeah, and it turns out that even when things maybe aren't running perfectly, say with our energy systems, exercise can still pack a surprising punch for keeping our minds sharp.
That's a great way to put it. And that's exactly what we're diving into today. Some really interesting new research from the University of Missouri. They're digging into this exercise-brain health connection.
Right, and the researchers leading this, Taylor Kelty and R. Scott Rector, their work feels incredibly relevant right now.
Definitely, especially when you hear these projections about uh, Alzheimer's diagnoses potentially shooting up in the coming years.
It really makes you pause and think, could something as simple, well, relatively simple, as regular exercise be a key defense against cognitive decline?
That's the million-dollar question, isn't it? And to really get what this Mizzou study is about, maybe we should quickly touch on brain fuel.
Good idea. So normally the brain runs on glucose, right? Sugar.
Primarily, yes. But when glucose is scarce, maybe you're fasting or on a specific diet, the liver steps in. It produces this alternative fuel called ketones.
Ah, ketones. Okay.
Yeah, and they're really important for things like memory, learning, basically a backup generator for the brain.
Got it. Backup generator. So the puzzle Kelty and Rector were looking at was what happens if that backup generator, the liver's ketone production, isn't working right?
Exactly, if it's limited somehow.
And crucially, can exercise still help the brain even then, even without that normal ketone supply?
That was the core question. So the Mizzou team set up a study to look specifically at that. What happens to brain function when hepatic ketogenesis, that's the fancy term for the liver making ketones, is compromised?
Okay, so they limited the ketone production. What did they see first? I mean, I guess the brain wouldn't function quite as well.
You'd be right. And that's what they initially found. Less ketone availability, because of that limited liver function, did lead to a noticeable dip in cognitive performance. Memory took a hit.
Right, as you might expect. Reduced fuel, reduced performance.
Pretty much. That part wasn't necessarily the big shocker. It lined up with their expectations.
But then came the twist, I take it.
Exactly. Here's the really cool part. Even with that impaired ketone production, putting exercise into the mix actually managed to reverse some of that cognitive decline.
Wow, okay. So exercise stepped in somehow.
It did, which suggests exercise has these other powerful effects on the brain that go beyond just making sure ketones are available.
That's pretty remarkable. It's like exercise found a workaround.
That's a good way to think about it. And Taylor Kelty, one of the researchers, basically said as much. She mentioned they weren't sure if exercise could overcome the impairment caused by fewer ketones.
Yeah, you'd think maybe the lack of fuel would be too big a hurdle.
Right. But her take was that exercise seems so potent, it likely triggers other beneficial mechanisms in the brain. It kind of bypasses the ketone issue and still delivers benefits.
Finding alternative routes, like you said.
Yeah. And R. Scott Rector, the other lead researcher, he really echoed that.
Yeah.
He pointed out how this study just highlights the sheer number of ways exercise benefits us.
Even if we don't know exactly how it's doing everything yet.
Precisely. He said, even if one pathway, like this ketone production, is blocked or impaired, exercise is doing so many other positive things that it can often compensate.
Like it has multiple tools in its toolkit for helping out.
You got it. Multiple levers it can pull, which is really promising news, especially for people who might have liver conditions.
Ah, right, because those conditions could naturally interfere with making ketones.
Exactly. And this research suggests that even for those individuals, regular exercise could still offer significant cognitive protection.
That's a really important connection to make the liver affecting the brain. We don't always think about those organ-to-organ links.
We don't, but it's a growing field.
Yeah.
Kelty actually mentioned this emerging area of liver-brain research.
Oh, interesting. What did she say?
Well, she noted that people with severe liver dysfunction often have a higher risk of developing dementia.
Okay.
And she proposed that maybe, just maybe, this disruption in the liver's ability to make ketones could be a contributing factor there. It could be part of why they're more susceptible to cognitive decline, maybe even conditions like dementia.
So it really underlines how interconnected everything is. A problem in the liver potentially impacting brain health down the line.
It really does. So the big picture here isn't just about exercise being good, though it certainly reinforces that.
Right. It also shines a light on how important ketone production itself might be for keeping our brains healthy.
Absolutely. And again, it shows exercise's power to help, even when that specific ketone process is compromised.
And it sounds like they're keen to keep digging into this at Mizzou.
Oh, definitely. Kelty sounded really enthusiastic about the resources they have there, the facilities, the potential for collaboration across different departments. She sees it as a great place to push this research forward.
That's great to hear. And Rector.
He seemed really proud of the university's commitment to this kind of work. He's been there a while and emphasized their hope, the collective hope, that these findings can eventually translate into ways to help a lot of people.
Which is ultimately the goal, isn't it?
Absolutely. And for anyone listening who wants to read the actual paper, it was published in the Journal of Physiology. The title is Cognitive Impairment Caused by Compromised Hepatic Ketogenesis is Prevented by Endurance Exercise.
Good to know. And who funded this work? Research like this takes resources.
It does. This was supported by the National Institutes of Health, the NIH. Specifically, through a program called the Molecular Transducers of Physical Activity Consortium, or MOTIRPAC.
MOTIRPAC. Okay, what's their main goal?
Their big aim is to really map out at the molecular level how physical activity actually improves health, getting down to the nitty-gritty mechanisms.
Which fits perfectly with this study, trying to untangle the different ways exercise impacts the brain.
Exactly.
Yeah.
Which loops us back to that really encouraging takeaway. Exercise seems to boost brain health through multiple routes. Not just by ensuring ketone availability, it's doing more complex beneficial things than we might have fully realized.
So summing it all up then, even when the brain's access to that key backup fuel, ketones, is limited,
Yeah.
exercise still shows this impressive ability to support and even partially rescue cognitive function.
It really does. And for you listening, someone keen on understanding brain health quickly and clearly, this is a real aha moment, isn't it?
Yeah, I think so.
It just underscores the brain's incredible resilience, its adaptability, and the really powerful, multifaceted role exercise plays in keeping it sharp long term.
Like you said, exercise is a master key, maybe, unlocking benefits even when one specific lock isn't working perfectly.
That's a great analogy, a master key for brain health.
So here's something to chew on. Knowing this, knowing that exercise can help the brain even when other things aren't optimal, does that change how you might think about fitting physical activity into your life? Not just for your body, but specifically for the long-term health and, well, the power of your mind.
It's a compelling thought. And it makes you wonder, what other hidden connections are there between our physical state and our mental state?
Yeah, what other surprising links between body and brain will future research uncover? It's quite an exciting area.